College Algebra, Chapter 3, Section 6, the last section in Chapter 3, Mathematical Models, Building Functions, or our word problems. So, that's what the objective is, just building functions, analyzing functions. We're going to go to page 267. And number 6. So they want us to, let's see, it says a right triangle has one vertex on the graph of y equals 9 minus x squared, x greater than 0, and, that's at point xy, another at the origin at 0, 0, and the third on the positive x-axis at x comma 0. They want us to express the area of the triangle as a function of x. So that's where we start here. Got to draw some things. See, first of all, let's write this down. A right triangle. One vertex first, I guess. Vertex on the graph y equals 9 minus x squared. X is greater than 0, and that's at the point xy. So what that means is if you put in an x value, it'll figure out the y. That's the point on the graph. So this x is important. Second vertex at the origin, and that's 0, 0. And the third vertex is at x, 0. And this x we have to assume is the same as the x we're going to use in the function y equals 9 minus x squared. So what does that look like? Let's see here. So here's the 9, we'll say, and here's the 3. So this is a parabola, opens down. The y-intercept is 9. It's got, when y is 0, x must be 3. It could be negative 3 too, but we just worry about positive x's. And the point is going to be someplace on here, xy. Another point will be at the origin, 0, 0. And if another point is on the x-axis, then it'll be the x-axis x0. So these x's, once we choose it, has to be the same. And they would like to know, I guess, if you do that, what is the area of this right triangle? Well, the area of any triangle is 1/2 the base times the height. They want this area in terms of x, the x-coordinate of the point, of either of these 2 points. So we need 1/2, and the base is going to be down here, which is just that distance x. And the height is going to be this leg here, this is the h, and that's going to be the y value for this point. But we don't want y, we want a of x, a in terms of x. So it means get rid of every other variable somehow. So I'm going to change that y because I know it is equal to y is 9 minus x squared. So this is, we could simplify it more perhaps, the function a in terms of x. Okay. Next one, number 18. This is page 267 still? No, it's the next page. 268. Okay, once again, I got to read this a little bit. Two cars leave an intersection at the same time. One is heading south at a constant rate of 30, and the other is headed west at a constant rate of 40 miles per hour for both. Express the distance d between the cars as a function of time t. So, we need to draw a picture. We've got this intersection. And the cars are heading west and south. So let's see. The one heading west is going at 40 miles per hour. The one heading south is going 30 miles per hour. The distance between the two cars is going to be that hypotenuse. Okay. We'll call this distance d, but we need these legs first. So they want this, they say, express the distance d between the cars as a function of time t. So t is the time the cars have traveled. Probably should be in hours. So since distance equals rate times time, each of these, the 30 miles per hour is the rate times the time. This becomes 30t. This is rate 40 miles per hour times the time. This is 40t. And then d is that distance for the hypotenuse, d of t. So in our case, we need, because this is a right triangle, we use the Pythagorean theorem, we need the 40t squared plus the 30t squared. And I guess you could multiply things out and get perhaps a nicer one, but that's 4 steps. And especially if I say on a test, don't simplify, just leave it like that and go on. So let's change colors a little bit. We might need a whole page. So let's go to a nice light blue for number 22. This one's on the next page, 269. I'm sorry, not 22, 24. Filling a conical tank. Water is poured into a container, shape of a right circular cone, radius 4 feet and height 16 feet. Express the volume V of the water in the cone as a function of the height h of the water. So first of all, I draw a picture. Here's the tank. It's not completely filled. That's a 4-foot radius. It is 16 feet tall, so from here to here is 16 feet. I guess we can draw that in here. But the water is not there. The water is sort of down here. And it's got a radius of the water that we're going to call r. And the height of this water, which we're going to call h. And this whole height is 16, and this largest radius is 4. So, what is the volume of a right circular cone? Well, it's 1/3 times the area of the base, pi r squared, times the height, h. This is really v of RH. It's this function v in terms of 2 variables. We don't want 2 variables. We want v of h. So we want to get r out of there. Well, how do we do that? Let's pull this right triangle out. along with the water's right triangle. Here's the R, here's the H. This whole thing is 16, and this is 4. These are similar triangles. So we know that their sides are proportional. R over 4 equals, R is the small, so we start with small h over 16. Now we want to keep the h. We want to replace the r, so we'll solve for r. R is equal to 4 times h over 16. Well, these will cancel. It's 1 and 4. So r is really h over 4. And that's what we'll put in here. 1/3 pi, not r, but h over 4 squared times h. Let's simplify this a little bit. So 3 times, this is going to be 16 here, right? 3 times 16 is 30 and 18, which is 48. So I'm going to put pi in the numerator, 48 in the denominator. And the h squared times the h is the h cubed. So this is a function in h. Used to be r and h, but we got rid of the r because we were given enough information to figure it out. Does that make sense? So that's what you're going to be doing for these problems. You're going to be using formulas. You're going to be using graphs. Draw a picture. It's worth some steps.